This is the AB 91 to 94 review. Calculators are not allowed, and this is number 2. So again, we are dealing with separation of variables. So the first thing I'll do is move this y and the dx. Integrate both sides. And if you remember, we always have the option of plugging in the point now or later. And when we have log naturals of absolute values, it tends to be easier if you isolate the y first before you plug in the point. The only variation on that is if plugging the x and y's in gives you zeros that are really nice to work with. In this case, when I plug in an x and a y, I'll have log natural of 2, which is kind of clunky, as my c. So instead I'm going to isolate the y first before I plug in that point. And remember, when I get rid of this absolute value, I'll do a plus or minus, and I'll use properties of exponents to split that exponent. That way I can treat this whole front number as just another random constant. And now I can plug in my point, where x is pi over 2 and y is 2. That tells me that a 2 comes out when I plug in a pi over 2. Well, cosine of pi over 2 is 0, so I get a c sub 1 is just a 2. So now I have my y isolated. I plug in my c sub 1, and my answer is there, or I can rewrite it without a negative exponent, which I think is what I did on my answer key. So if we look at B, same process. I'm going to move this y to the other side and the dx to the other side. This one integrates pretty readily to a log natural of absolute value of y, but this other side's a little tougher. So let's look at how we do that other side. I'm going to pull a little paper off here so we can do it separately and then still have room. So this ln of x over x is not anything on our green sheet, so we're going to have to solve it using our substitution method. So we're going to look for a u whose derivative is also in there. Remember that the derivative of log natural of x is 1 over x, and that's in there. And we've got this dx. So we've got to remember what we did in section 5.5. In 5.5, we wrote down what our u was. Then we found our dx, which was a du divided by the derivative of that, which is actually x times a du. Then we rewrote this, leaving everything the same except for the boxes. And when we do that, we end up with just a u du, whose antiderivative is going to be, let me skip this here, a u squared over a 2 plus some constant, and then we can put our u, which was log natural of x, back in. So that right-hand side, which was kind of difficult to figure out, this right here, we had to do an entire substitution method to get its antiderivative. But now that we know what its antiderivative is, we can put it in, and we're ready to move forward. So again, I've got a y trapped inside a log, and in this case I've got 1's and e's, so it'll probably work out either way. It wouldn't matter which one you want to do, but because I want to retain that protocol and kind of practice isolating the y first, we'll do that. So first I'm going to isolate the y by raising both sides as exponents of e. Then I'll get rid of the absolute value and split that exponent. Then I can rewrite that as another constant. And I'm ready to plug in my point, which is y gives me a 1 when x is an e. So if I plug in an x side is an e. I get e to the log natural of e, which is a 1. Squared is a 1/2, so I have e to the 1/2. So my c will actually be 1 divided by this, or e to the negative 1/2. So now I'm ready to go plug it back in. I'll get y equals an e to the negative 1/2 times an e to the log natural squared of x over 2. Remember, if the bases are repeated, you can add the exponents. So we'll end up with y equals an e to the log natural squared of x minus 1 all over 2. And we're done. So last part, c. Again, we need to isolate or separate, so I'll move the y to the other side, the dx to the right, integrate both sides. What do I take the derivative of with respect to x? It gives me cosecant squared. Well, that's a negative cotangent. If I isolate my y now, I'll e both sides. Then I'll have the plus minus. Forgot my plus c. And pull that e to the c apart. So now I can treat this as another random constant. And I'm ready to plug in my point. So the point is, when x is pi over 2, y is going to be 3. And let's recall that cotangent is cosine over sine, and the cosine of pi over 2 is a 0. So we'll get e to the 0, which is just a 1, so c sub 1 equals 3. Therefore, we can plug our c sub 1 back in, and we're done, or we can get that exponent written as a positive, and we're finished.